So yesterday we studied flash type ADC. Do you remember flash type ADC? Attendance is very less, so everybody join the meeting. I am using whiteboard so that there should not be any problem in reading the things. Okay. So what is a flash type ADC? How many number of comparators are required in flash type ADC? Yes. Yes. Correct.
7.
7 comparators are required if it is a 3-bit ADC. Okay. So in general, for any ADC which is flash type, you need 2 raised to n minus 1, where n is a number of bits. So if I ask you 2-bit or 3-bit, so number of comparator will change. In yesterday's discussion, we considered the comparator with 3 bits. Therefore, the number of ADC required was 7. Okay. In this example, 1, 2, 3, 4, 5, 6, 7. Why? Because this is a 3-bit ADC. So for 3, if you calculate 2 raised to 3, that will be 8 minus 1 equal to 7. Therefore, this is a 3-bit ADC. Therefore, you need 7. So if I ask you 4 bits, so you have to calculate 2 raised to 4 minus 1, right? And number of resistors that are required is equal to 2 raised to n. So because we are using 3-bit ADC in this example, so 2 raised to 3 equal to 8 number of resistance we have used. So how we have connected, I just shortly revise. So basically to every non-inverting terminal, we have combinedly given the input voltage, and the inverting terminal of every comparator was connected to some reference voltage, and this reference voltage were different for every comparator because we have connected every comparator to some resistor, to the network of voltage divider. Okay, so whatever reference voltage will you give, accordingly, here there should be one more resistance, accordingly the different voltages forms the different reference level. So when your input voltage come, it is compared with all the comparators, those comparators where the connected input voltage is greater. So that comparator will give you plus Vsat, and if it is less than the reference voltage, that comparator will give you minus Vsat. Plus Vsat forms logic 1, minus Vsat form logic 0, and this way the digital output, the output of every comparator is in the form of high or low. So to all these output, we are connected to 3-line to 8-line priority encoder. So it will convert your input logics, which is forming some word, into binary output with 3 bits. So if all are 0, output is 0. If this is 1 and all are 0, it means input to 3-line encoder is 0, 0, 0, 0, 1. So accordingly, it will give you output equal to 1, equivalent in 3 bits. So 0, 0, 1 will be the output. So this way you have connected, you have learned flash type ADC. So this is the fastest because all comparators are working simultaneously. Okay, moment you apply here, all are producing the output, all are working simultaneously. It is not like one by one they are working, they are producing like a serial communication. So all are working parallelly together, and therefore the working or the time required for conversion is high. So it is the fastest ADC among all. What is the advantage? It is fastest, its speed is very high. But the problem is that the number of comparators is very high. If you want to have 32-bit, so you can imagine how many number of comparators are needed. Okay? So therefore, we prefer another type of ADC. Now let us have use. The next ADC we will use is a counter type ADC. Okay? The next ADC we'll use is a counter type. counter type ADC. Now, if you see the circuit diagram for counter type ADC, you will find it a bit easier as compared to the previous. So what is there? Let's draw this circuit diagram. So you will be using an n-bit counter. What is this? N-bit counter. Have you studied n-bit counter in digital electronics? शिकल्यात का? Counter? Your portion is over, I think. So you must have studied counter. Digital counter, have you studied or not? Counters, different types of counter you have studied. So what is basically the purpose of a counter? काय करतं counter circuit? It counts the number of pulses. If you are giving input, at the input of this, if you provide some pulses, it will count the number of pulses. So this is n-bit counter. It will count the number of pulses. Then what we'll do, the output of this counter is given to digital to analog conversion. See how is this circuit. DAC we have studied already. Okay. Now we are studying ADC. But in this ADC circuit, we are employing DAC also. So for this counter, there are output pins. So let's say 1 to n I am drawing. So this is 1, pin 1, 2, 3 and so on up to n. So it can produce, because this is an n-bit counter, it can count up to n. So let it be n number. Now output of this n-bit counter we will give to DAC, digital to analog converter. Hey, what is this? Digital to analog converter. Next block काय हा? DAC. ADC मध्ये DAC सुद्धा येतोय बघा. Digital to analog converter, and we have studied DAC. What DAC do? It receives digital input and convert it into equivalent analog output. So now this DAC is receiving its input word from n-bit counter. Okay. Now this DAC will produce the output which will be analog in nature. So this is the output of DAC. Okay. This output will go to a comparator. So we have a comparator. We have a comparator such that the output of DAC is given to the negative terminal, that is inverting terminal. And what about the non-inverting terminal? We will apply the second input to the non-inverting terminal. And what is the second input? What we are learning, analog to digital converter. आपण काय शिकतोय? Analog to digital. म्हणजे analog signal मला द्यायला पाहिजे. So this analog signal we will give to this comparator. Okay. What is this? This is a comparator. This is a comparator. हा comparator. या comparator ला एक input कुठनं मिळतोय? It is receiving one input from DAC. Okay. Second input is your analog signal. So here it is receiving the analog signal, which we have to actually convert. So this is your analog signal. हा झाला तुमचा analog signal. कुठे दिला? Comparator ला. Now output of comparator. This is the output of comparator. It is given to a clock. Or it is given to a gate. Okay. So this output is given to a clock producer. So here it is providing a clock. Okay. So at one end of this AND gate, What is provided is a clock. You are familiar with clock pulses? So this is an AND gate. To this AND gate, at one end we are providing clock, and at another gate we are providing the output of comparator. And this we are giving as input to our n bit counter. Understood circuit diagram? Okay. So this is your analog signal. This is your analog signal. You are giving your analog signal to the comparator. Here is your input. Okay. And this is a n bit counter. Now what counter is receiving? Number of pulses. Counter count kai karto? Pulses. It counts the number of pulses. So when this train of pulses is passed through the n bit counter, it will count at every high. Okay. So first pulse, second pulse, third pulse. Moment these pulses are producing, passing through this counter, it will give you output 0001 or 0010, 0011. If it is a 4-bit counter, कसा देईल तुम्हाला? जेव्हा कुठली पल्स जाणार नाही तेव्हा याचा आउटपुट काय राहील? 0000. और एक पल्स पास झाली की आउटपुट देईल हा 0001. सेकंड पल्स पास झाली की 0010 likewise. And that depends, maximum count depends on the number of bits that are passed. Sorry, किती bit counter है? 2-bit counter है, 3-bit counter है. Accordingly, it will give you the output. So this is what the counter type counter type ADC. हा झाला तुमचा counter type ADC. Now see how it work. Let's check how does it work. So first of all, when there are no pulses, let us assume that this is a 4-bit counter. A 4-bit counter hai. 1, 2, 3, 4. So I have drawn here so that I will extend it to show n-bit counter. And आता या example, let it be 4-bit counter. It means it is going to count the number of pulses in 4 bits. So you can have combination from 0002 to 1111. एवढे number of pulses हा counter count करू शकेल. Tejal, am I audible?
Yes, ma'am.
So now initially, see, one thing remember, this is an AND gate. And when AND gate produce output equal to 1, when all the inputs are high, then only output is high. If any one of the input is low, output will become 0, right? Because it's an AND gate. So this pulse, high pulse will appear here only when, इथे तर आपण clock देतोय. Here we are giving clock. So clock is becoming high. This clock is becoming high after every time interval. So when there is a clock and when the output of comparator is 1, then only the clock will be passed, that 1 will be passed. Okay. If clock is 1 but comparator's output is 0, this will be 0. Output of AND gate will be 0. Okay. So let's take an example of 4-bit counter. So see how it is counting. So this is your VA. Let's make your VA. This is your VA, analog input. And here it is receiving some reference analog input. Every time this will be changing. So initially, when there is no input to the counter, so it will produce output equal to 0, 0, 0, 0. Okay. So initially when there is no input, output will be 0, 0, 0, 0. So this DAC will receive that 0, 0, 0, 0 and it will convert it into equivalent analog voltage. So equivalent analog output for all 0 is 0. So here it will become 0. Now this is a comparator. This is analog signal and this is the another analog signal. हा जो 0 आहे किंवा इथे जे काय व्होल्टेज येणार आहे याचं नेचर काय आहे, हा डिजिटल टू एनालॉग कन्व्हर्टर आहे. सो इट इज मेकिंग दॅट एनालॉग व्होल्टेज. नो कंपॅरेटर इज कम्पेअरिंग टू एनालॉग व्होल्टेजेस. काय करताय तो, टू एनालॉग व्होल्टेज कम्पेअर करताय. अँड विच एव्हर इज ग्रेटर it will provide output accordingly, either plus reset or minus reset. That is either high logic or low logic. Okay. So now this is 0 and this is your input signal. So what will be the output? 0 is less than this analog input. So output will be plus reset. बरोबर. हा input मोठा आहे because first number is 0. Reference voltage काय आलं इथे 0. All bits are 0 because there is no input. All bits are 0. 0 is converted to analog voltage of 0. This 0 is compared with the analog signal. Okay. So for example, now we can assume that analog voltage is having higher value. हा lower पण असू शकतो जसं त्याचं nature असेल. So let's consider that this is high. When this is high, the output of comparator will be 1. And therefore, this AND gate will receive 1. Barabar? Now there is a clock and there is 1. So output of AND gate will be 1. Clock will pass. So first clock passes. So what will be the output of DAC? पहिली clock गेली तर DAC output किती देणार तुम्हाला? Sorry, not DAC, counter output किती देणार? Counter will give you output 0. पहिल्यांदा काय होतं 0 0 0 0. First 0 0 0 0. Okay. Then output of your DAC was 0. Output of comparator झालं DAC. And comparator काय होतं? It was logic 1. Logic 1 झाल्यामुळे AND gateचं output काय झालं? 1. Therefore first clock is passed. Therefore counter will count it as a 1 clock and you will get output equal to किती का पल्स पास झाली 1. सो 0 0 0 1. याचा आउटपुट काय झाला आता 0 0 0 1. So this 0 0 0 1 will go to DAC. हा digital data DAC ला गेला, right? DAC what it will do? It will convert it into analog. So equivalent of 0 0 0 1, let's say it is 1 volt. Analog किती होणार? 1 चा analog 1. Okay. आपण पाहिलं की DAC कसा आउटपुट करतो एनालॉगला. सो 1 बीट झाली तर हा 1 व्होल्ट देईल. सो हिअर नाव आउटपुट will become 1. Analog आहे 1 volt. This 1 volt is analog. Okay. So DAC output will be 1. What will be the output of a comparator? This is 1 and this is your analog input. Now again it will compare whether this 1 volt is greater or analog input is greater. If analog input is greater, what will be the output? If analog input is greater, output will be 1. So assume that analog input signal is still greater than 1 volt. So again here there will be both 1 and 1 more clock pulse will pass. Okay. So in this case also comparator's output is 1. And therefore 1 clock pulse is passed. So 1 more clock pulse is passed. So now what will be the output of a counter? What will be the output of counter?
0 0 1 0.
0 0 1 0. And 2 clock pulses झाल्या. So 0 0 1 0. Now what will be the output of DAC? What will be the output of DAC? 0 0 0 1 म्हणजे इक्विव्हॅलेंट काय झाला? डिजिटल टू एनालॉग कन्व्हर्टर इज गोइंग टू करेक्ट. इट इज गोइंग टू कन्व्हर्ट इट इनटू एनालॉग सिग्नल. तर 0 0 1 0 हा जर डिजिटल आहे तर त्याचा एनालॉग इक्विव्हॅलेंट काय? व्हॉट इज इट्स एनालॉग इक्विव्हॅलेंट? 2 व्होल्ट. सो DAC विल गिव्ह, हा नंबर किती झाला? 2 झाला ना. डिजिटल मधल्याचा डेसिमल करा म्हटलं तर किती होईल? 2. सो DAC's output will be 2 volt and therefore comparator output will be, now again a comparator will continue till what time this process will be repeated? The process कधीपर्यंत repeat होणार बघा. Whenever VA in analog signal is higher, output you will get 1. Suppose now this 2 volt is greater than analog signal. So what will become? The output of comparator will become 0. So in that case, there will be no clock pulse passed. Okay. So will the output of the n bit counter will change? चेंज होईल का? जर इथे 0 आला, हा 4 बिट काउंटर आहे. एक्झाम्पल 4 बिट काउंटर आहे. And in the 4 bit counter, it is about to count the pulses equal to 1, 1, 1, 1. 2 raised to 4 means 16. Up to maximum 16 it is going to count. So whenever VA is greater than, let's call this voltage as VD. याला VD म्हणूया, DAC चा output. Whenever VA is greater than VD, your comparator's output will be 1 and therefore clock will be passed. If VA is less than VD, this AND gate will be disabled. ओके, म्हणजे लेवल जी आहे इनपुट सिग्नलची ती एवढ्या व्होल्ट पर्यंत, whenever it is equal or greater than, okay, whenever this VP is equal or greater than, it will become 0 because it is connected to minus. So minus reset, that is logic 0. Logic 0 झाला की there will be no further clock pulse passed. Okay, I will try to draw this. या केसमध्ये this gate will be disabled. Analog input voltage, हे analog voltage जे आहे इथे दिलेलं, याची इक्विव्हॅलंट व्हॅल्यू किती आहे, जी या काउंटरच्या आउटपुटला येते. ओके, ज्या केसमध्ये सपोज नाव युअर एनालॉग इथपर्यंत आपण आलो 2 व्होल्ट. नाव सपोज दिस इज लेस दॅन और ग्रेटर दॅन म्हणायला पाहिजे. इथे 2 व्होल्ट आलाय. नाव 2 व्होल्ट इज ग्रेटर दॅन VA. व्हॉट विल हॅपन? 2 व्होल्ट इज ग्रेटर दॅन VA. So what will be the output of a comparator? आता analog signal less आहे and VD is high. What will be the output of comparator? Minus reset, that is equal to low logic. Therefore AND gate will be disabled. AND gate disable झाले, so no further clock will be passed. आता या केसला इथे काय मिळालंय तुम्हाला, जिथे स्टॉप झालाय, whenever it is stopped, now what is there on the n bit counter? 0 0 1 0. म्हणजे ही गोष्ट आहे. याचा अर्थ तुमचा इनपुट एनालॉग सिग्नल has now reached to 2 volt. 2 volt आलाय. So the equivalent of this analog signal at that instant will be output of a n bit counter. n bit counter च्या आउटपुटला ज्या बिट्स आहेत 0 0 1 0, so this analog signal is converted into digital form. जोपर्यंत ही प्रोसेस रिपीट होते, moment these two signal will become equal or the output of DAC will become greater, then this AND gate will be disabled, and at that time the analog voltage will be equivalent to whatever is there at the output of n bit counter. So in our condition, in our example, 0 0 1 0, it means that इथे जो सिग्नल होता 2 व्होल्टचा होता आणि 2 व्होल्ट हे दोन्ही 2 व्होल्ट झाल्याबरोबर ही प्रोसेस स्टॉप झाली and last what I got here is 0 0 1 0. So 2 volt analog is converted into digital form, that is 0 0 1 0. Analog to digital converter using counter type ADC. Have you understood, everybody? So these are the clocks. Suppose you are starting the clock. You can simultaneously take down. तुमचे notes काढा. Take down, take it down. This is, please show it by dotted line. The yellow color line, please show it by dotted line. So this is your clock. What is this clock? So when there is a high clock, your output of DAC count it as 1 pulse. 1 pulse is counted here. Okay, till what time? जोपर्यंत दुसरी clock येते, 1 pulse count झाली. Then suppose this is VD. Then a second clock pulse comes. So output becomes equivalent to 2 clock pulses. Third clock pulse comes. This is the output. Now at this instant, इथे whatever analog input you have applied, okay, and the digital input, they are becoming equal. इथे दोन्ही equal झाले. Moment it becomes equal, this output will become 0. So at this moment, 1, 2, 3, 4. What you got? जितक्या pulses pass झाल्या तेवढा count त्या counterच्या outputला होता. The counter output was showing the number of pulses which was passed. And that time when the analog voltage and digital voltages are becoming equal, your AND gate is becoming disabled and no further clock will pass. So till that time, whatever the count exists here, that is equal to the value of this analog voltage. So in this case now 1 1 1, इथे मी 3 साठी काढलं 1 1 1. 0, sorry, here it will be 0 0 1 1. जर 4-bit counter म्हटलं तर 0 0 1 1. So this way analog signal is converted to digital signal. Once again revise. So we are using a AND gate which is passing the clock signal. So the clock signal to be passed, both other input of this shall be 1. So there is an n-bit counter. The output of n-bit counter is available on these lines, output lines of this counter. The whatever word is available here, that is converted to analog form with the help of DAC. या ADC मध्ये एक DAC आहे. Okay, digital to analog converter. After converting to equivalent analog value, the comparator is comparing this analog voltage with the applied analog voltage. And applied analog voltage is connected to the non-inverting terminal. Therefore, whenever VA is greater, the output of a comparator will be logic 1 and further clock will be passed. But when the VD signal and VA signal become equal, or when VD becomes greater, then the logic produced by the comparator is -1. Therefore, further counting is stopped. And at this moment, whatever is the data available on the output of counter, that is the digital form of this analog signal. तोपर्यंत जेवढा काउंट जातो आहे इथे तो आहे. So this value equal to this analog voltage is equal to this digital data which is present at the output of n-bit counter. Have you understood? Yes. कळलंय का?
Yes, ma'am.
काउंटर टाइप ADC कळलंय तुम्हाला? Any doubt? Now we'll take the next comparator as successive approximation. Better I will draw it. Let's take the next as successive approximation. Successive approximation ADC. Successive approximation ADC. Let's draw the diagram. Now we are going to use here a register called as successive approximation register. How it works, you'll see. So we'll be using शिकलात का तुम्ही डिजिटल इलेक्ट्रॉनिक्स मध्ये successive approximation register. So you have a successive approximation register, and this register receives two signals. One is start of conversion, another is end of conversion. Output of this is end of conversion, it receives. It start working after it receive a signal called as SOC. SOC means start of conversion. Okay. And it stops working when the output becomes high at the pin called end of conversion EOC. Akshat, right? It receive SOC, then it start working. And when the working is over, it gives end of conversion signal. Now conversion is ended. And there are a number of outputs depending on how much bits are used. So let's draw. One, two, three, four. Let it be 4 because I will give an example of 4. And all this bit again goes to DAC. So here is there again there is digital to analog converter DAC. This is your DAC. So this is your bit number 1, 2, 3, 4. So let's say that this is your पहिली MSB and may this be your LSB. Okay, n numbers of bit असणार आहे. So this is your MSB. First is MSB and second is this last is LSB. Output of DAC is then given to the comparator. परत आपल्याकडे comparator आता. This is the comparator and its output will go to successive approximation register. This comparator is receiving two signals. One is output from DAC. The output of DAC is given to the comparator. Let's call this as VD. And at the another end of comparator, we are giving the input analog signal. ज्याचे conversion करायचं. The signal which we want to convert into digital, that is given to this comparator. All the comparators must be given supply voltage. In the block diagram, no problem if you forget to give. But in the circuit diagrams of all op-amp, don't forget to give this. So what is this block? This is a comparator block. Okay. And to this successive approximation resistor, clock is also applied. You are applying clock. So this is the block diagram for successive approximation analog to digital converter. In the previous comparator, in the previous comparator, this circuit was simple. Okay, it is simple as compared to ADC with flash type ADC peksha हे circuit easier, right? There is one n-bit counter, DAC comparator and a AND gate. Circuit is easier, less complex, therefore less expensive. पण याला conversion time किती लागतो बघ. Every bit passes, then successive flash type ADC मध्ये what was happening when the input was given, all the bits, all these comparators were becoming working simultaneously. Barabar? All comparator were working simultaneously. Now here see how is the working. First clock pulses pass, then it produces a result, then that result is compared, then second clock pulse is passed. So after every end of the every clock pulse, the n-bit counter is making available digital output at its output pin. Therefore, conversion time required आणि हे किती लागतो याला time 2:n-1. 2:n-1 this much is the conversion time is required. Therefore, these are little slow. That is the disadvantage. Now next we will see a successive approximation resistor. So successive approximation resistor will start working when it receives the SOC signal, start of conversion signal. Now how this work? When it receives here high signal, it produces याचे जे outputs are initially all are zeros. Okay, initially all are zero. When it receives high, जेव्हा इथनं याला high मिळतो, logic high means 1. So that time, first of all, the output of SAR is 0. 0, 0, 0. Suppose it's a 4-bit, then it is 0 like this. This is your most significant bit and this is your least significant bit. When it receives here high at the input, it is a 1 ala. What this SAR do? It makes its MSB 1. It makes it MSB 1 and let all other remains 0. Again, for the next clock pulse, if there is again 1, are you getting? In the next clock pulse, again if there is 1 high, if it receives high, what it do? It keep the first MSB high and makes the second one high. हा वर्क कसा करतो बघा. सुरुवातीला all 0. ऋतुजा, am I audible clearly? Am I audible?
Yes, ma'am.
Okay. So how it works here? First of all bits at the end output of SAR are 0. When SAR receives the input and when it start working, SOC signals right. When it's SOC, whenever I have to start conversion, I have to first make SOC 1. So it understand now I have to start working. So when it receives the input as high, it set its MSB to high. Okay, and rest of the bits are again same, that is 0. In the next clock pulse, suppose it again receive 1, it will keep its previously set MSB same and makes the next MSB as 1. But suppose it receives low. Second clock pulse ला जर याला low मिळाला. Suppose instead of 1 it receives 1. What it do? It set the first MSB to 0 and make the next one. Are you getting? जर इथे 1 आहे आणि इथे पुन्हा 1 आला तर हा सेकंड MSB again it set 1 and makes the rest 0. But if this is not 1, if it is receiving 0, so it make its first MSB 0 and make the second one 1. Now at the third clock pulse, suppose it again receive 1. So what it will do? It will keep this 1 as it is and make the other one. जर याला इनपुटला 1 आला तर ऑलरेडी सेट केलेली एमएस बीट हा 1च ठेवतो आणि दुसरी 0 करतो. पण याला 0 आला तर आधीची जो आहे तो 0 बनवणार आणि पुढची बनवणार. ओके, this way it works. So let's take an example. I have started attendance already. Please mark the attendance. Let it be. Now let's assume that this is a 4-bit ADC. 4-bit ADC means you will get the equivalent for analog signal in the 4-bit number. Analog to digital converter. When I say it's a 4-bit DAC, so it will use only 4-bit to represent your analog voltage in the digital form. Where is our analog voltage? Here, VA. So let this VA is equal to, let's say, 11 volt. How much? We will take an example that the voltage which is present, the analog voltage is of 11 volt. Now we'll check how this will perform. Okay, so this is 11. So it start the conversion. When it start the conversion, it set its MS bit to 1. It has started conversion. It's a 4-bit. All are 0 previously, MS bit, and this is LS bit. So it makes it first bit 1 and rest bits 0. So its LS bit is now 0. Then what is our input voltage? Let's say it is 11 volt. 11 volt. So what is the output of SAR? 1000 means now it goes this 1000 1000 is SAR's output. This output will go to DAC, digital to analog converter. What DAC will do? It will convert it into analog. So can you tell me what is the analog equivalent of this? DAC तो convert करून देणार आहे, पण हे किती आहे analog? How much this is? You can apply it for 2-1 code always. किती आहे तो? हा नंबर किती आहे? It's a decimal equivalent सांगा. 8421? Yes, 8. See how to count. 8. किती bits आहे तुमचे? 4 आहे. 8421 code apply करा. If you want to write 1, so make the bit below this rest of 0. If you want to write 4, make this bit 1, let all high. Now if you want to write 6, then make this 4 and this 2, because 4 plus 2 is 6. So make this 2 and let. If you want to write 5, then 4 plus 1, 5. So make this 1 and this 1, rest 0. So this way it becomes very easy to check what number is this. हे शिकला आहे तुम्ही डिजिटल मध्ये. Learn this in digital electronics. Okay. Now next, okay, what is the output of DAC here? It will convert this signal into analog form, so output will become 8 volt. Output will become 8 volt. Now what this comparator will do? 8 volt will be compared with the 11 volt. What is greater? 11. So, okay, this is minus. One important thing I have drawn. The input analog voltage is applied at inverting terminal and output of DAC is connected to non-inverting terminal. So what will be the output of comparator now? Plus Vsat or minus Vsat? Now it is operating on the clock pulses and what data it is receiving. Okay. What will be the output here? 1 or 0? Analog input is 11 volt. DAC's output is 8 volt. What shall be the output of a comparator? 1 or 0? It should be 0. Plus Vsat राहणार की minus Vsat राहणार? Analog input कुठे connect केलेलं आहे? This is your analog input. जे 11 volt आहे, for example. And this is your output of DAC. So output of DAC किती आला? 1 0 0 means this is equivalent 8. So DAC will give you 8. Now 8 is compared with 11. 11 is greater. It is connected to negative terminal, inverting terminal. So output will be minus Vsat. That is logic 0. Clear? Understood, everyone? So output will be 0. So this is 0. So at the next clock pulse of this SAR, it will find it has received 0. काय आलाय? 0. तर हा काय करणार? When it has received 0, when analog voltage, how it affects actually whenever VA is greater than VD. Whenever VA is greater than VD, so it's set its next bit to 1. It means it should receive 1. Let me check it from a reference book. Okay, I will check it from the reference book. So probably this shall be plus and this shall be minus. Then only you will receive here the logic 1. Okay. So in this case now you will receive logic output 1. So when SAR receives 1, what it will do? It will keep its previously adjusted, previously set bit as it is, and it will make the next bit as 1. फक्त एका बिटचा change होतो. Rest bits are 1 0 0. So now what is your second input? 1 1 0 0. So DAC receives 1 1 0 0. Okay. So now what the output of DAC will be? Yacha equivalent काय 1 1 0 0? 12 volt. Okay. So output of DAC will become 12 volt. I can write here 12 volt. Now this 12 volt and this 11 volt, what will happen? What will happen? This is 11 volt analog input and VD is becoming 12 volt. What will be the result? 12 volt. So this will be set, this will become 0. When SAR receives 0, what it will do now? It या second case मध्ये यानी ही bit set केलेली आहे. Okay. So what it will do? ही जी आधीची bit set केलेली आहे, it will change to it and make the next one. Because the third step is happening. So third bit it will set to 1. But it has received 0, so it will make previously made 0. So in this case, the first bit will remain as it is. This bit will change to 0 and third bit will set to 1. Fourth bit will remain as it is. Okay, 1 0 1 0. So now what is the next status? 1 0 1 0. SAR चा output काय झाला आता 1 0 1 0, which is going to DAC. So what DAC will, is 11:30. What DAC will give the output? 1 0 1 0 is 10 volt. So now what is the thing? Output will become here 1. 1 आल्यावर हा काय करणार आहे? आतापर्यंतचे सेट केलेल्या बीट बघा अशा 1 0. Previously set bit is this and it has received 1, so it will keep this bit as it is and make the next bit as 1. It will make the next bit as 1. Now what is this? 1 0 1 1. What will be the output of DAC now? 11. So this is 11, this is 11. Output will switch to 0. Okay. In this case, now VA and VD are becoming equal. Okay. So at this condition, conversion will be stopped. It will be end of conversion. When both the signals become same, equal, there will be end of conversion. So after end of conversion, now you read this digital output. याचा जो लास्ट आहे आता हे मी लिहिलंय याच्या खाली ऍक्च्युअली काय राहणार, हाच राहणार 1011. So what was your input? 11 volt, and what is your digital equivalent? 1011. So this way this analog voltage is converted into digital form. You understood? Really? Now because my course plan is ended, I will not able to store here, so I'll take the attendance. Let me check. Please give your attendance. Please give me a pen. हॅलो. वैभव भंडारगे सेव्ह होत नाही. इफ पॉसिबल प्लीज मार्क. इथे मार्क करा कारण ही सेव्ह होणार नाही. सो मी आय विल नोट इट. ओके, आय विल नोट इट. वैभवी भोसले, हर्षदा चौधरी, यश लवाटे, यश लवाटे, हॅलो. मियालाल मुल्ला, समृद्धी पाटील, ओमकार फरांदे,
प्रेझेंट.
पार्थ सावंत, पीयूष सावकर नहीं, शुभम श्रीसाठ, तेजस सोनवणे, अक्षय सुतार, यज्ञेश वरपे,
मॅम 20 प्रेझेंट.
20 मार्क आहे ना.
22.
I'll take the name of absent students. यश लवाटे 24, मियालाल मुल्ला 26, समृद्धी पाटिल, you can take your break. समृद्धी पाटिल 33, पीयूष सावकर 40, शुभम श्रीसाठ 43, अक्षय सुतार 47. You can take break. Yeah, you can take your break. And Yadnesh Varpe 49. Okay, this is not saved. I have written your number. I will write in the blue book.